All right, here we go. I'm going to go ahead and get started, guys. So, what you're looking at is the exam from 2022. It was the 9 weeks exam. And as you can see here, that year was 40% on paper and 60% Delta Math. Tomorrow, it will be 100% Delta. So, I don't know if that's a good thing or a bad thing. I don't have any papers. There, grab that one. Someone was passing them out, and there should be all over the place. Look, there's an extra paper right here. No one sits in that table there. All right, here we go. First one, guys. Guys, focus. It says h of x equals f of x times g of x. What rule do I got to use to find h prime of negative 2? Product rule. So here we go. H prime of x equals first times derivative of the second plus second derivative of the first. I don't think anyone will have any issues with these right here, the first ones, A, B, and C. So h prime of x, or h prime of negative 2, is equal f of negative 2, g prime of negative 2, plus g of negative 2, f prime of negative 2, and we're just going to plug in. I'm going to look at negative 2, and pretty much I'm looking at all of these right there. So let's see, f of negative 2. F of negative 2 is negative 1. G prime of negative 2. G prime of negative 2 is 1 half. And then plus g of negative 2 is positive 3. And then f prime of negative 2 is 2/3. And then you just multiply them. So negative 1 half plus 2. So that's going to be 1.5. Or you can say 3 halves. What do you guys think? Not bad, right? Letter B, what rule? Quotient. Some of you reversed it. M prime of x. I'll pass out your exams. I have them over there. I'll pass them out in a little bit. Bottom times derivative of the top. Plus or minus. Minus top derivative of the bottom. All over bottom squared. And now I'm just going to plug in. M prime of 1 equals g of 1. I'm going to come back up there. G of 1 is negative 2. Let me know. I mess up all the time. F prime of 1. F prime of 1 is 2. Minus f of 1. F of 1 is 1/3. Times g prime of 1. G prime of 1 is negative 4. All over bottom squared. G of 1 is negative 2 squared. Hopefully I didn't mess up. Negative 2 times 2 is negative 4. Negative times a negative is a positive over 2 squared, which is 4. Common denominator in the numerator. Multiply this sucker by 3 over 3. Let's see what we get. Negative 12 over 3 plus 4 over 3 divided by 4. Keep, change, flip. Negative 12 plus 4, that's going to be a negative 8 over 3 times 4. That 4 goes into 8 how many times? So negative 2/3. How are we feeling, guys? Okay. What rule for letter C? Chain rule. It's just pure chain rule. P prime of x. I guess let me change the color because we're running out of space and I don't want you to confuse it for the other stuff. P prime of x equals derivative of the outside, leave the inside alone, times what? Derivative of the inside. Good job. I'm just going to plug in a negative 1. P prime of negative 1 equals g prime f of negative 1 times f prime of negative 1. I look up what f of negative 1 is, and I'll slow down. What's f of negative 1? 4. G prime of 4 times f prime of negative 1. Someone tell me what g prime of 4 is. What is it? 4/3. Times what's f prime of negative 1? Negative 3 over 2. Yes, negative 3 over 2. I wrote that right? Okay. The 3's cancel out. It's still negative. 4 divided by 2, negative 2. Do you guys see how we got it? And there it is. How are we feeling, guys? All right. I know, not the most exciting. Once we start doing in context, it's going to get really good, really fun. What rule? What 2 rules? Product in combination with chain. So recognize first, second. Make a little note that this guy here is g of x to the 1/2. Just make a note somewhere. See? So here we go. Q prime of x equals, they want to know q prime of 4. First times derivative of the second. Giant parenthesis, here we go. I'm going to go slow. The derivative of the second is you bring the 1/2 to the front. Parenthesis, g of x, close, close, to what power? Negative 1/2, good job, times the derivative of the inside, which is g prime of x, close giant parenthesis. That is the derivative of the second, all that right there. Am I done? No. Plus the second, you could write a g of x to the 1/2, but just write it like this, square root of g of x, since you're going to leave it alone, right? Times derivative of the first, f prime of x. How do we feel? Maybe you want to write it prettier. G prime of x equals, let's see, I see this g prime stays on the top, so I'm going to have f of x here like this times g prime of x over 2 square root of g of x. Let me see if I see any issues. I think we're pretty good right now. Plus, and then this I'm going to leave alone, square root of g of x times f prime of x. Okay, we're ready. Q prime of 4. What is f of 4? 3. Thank you. What is g prime of 4? 4/3. I guess I'll write it like that for now. You could bring that 3 down and put it with the 2 there. 2 times 3. And then square root of g of 4 is 4, so square root of 4. We'll fix it right now. Times square root of 4 times f prime of 4, which is negative 3. Did we make any mistakes? Okay, I'm going to go slow. You could use your calculator, but check it out. This 3 is going to cancel with this 3. Do you guys see that or no? And then 4 divided by 2 is 2. And then the square root of 4 is 2. So 2 divided by 2 again is 1. So I see 1 minus the square root of 4 is 2. 2 times negative 3 is 6. 1 minus 6. Negative 5. Let me know. I make mistakes. Let's see. 3. 2 times 2 is 4. 4 divided by 4 is 1. Square root of 4 is 2. 2 times 3. Nope. That was good. Okay, now we're getting into some funky derivatives. Letter E. F of x. What rule or what? What am I doing? I want r prime, so what rule do I got to use? Yeah, chain. R, that's not an R. R prime of x equals derivative of the outside, leave the inside alone, times derivative of the inside. And no yawning, that's a demerit. I'm kidding. That's a joke. That's a joke, YouTube. R prime of negative 2 equals, all I'm doing is plugging in a negative 2, guys. F prime, F of negative 2, close, times F prime of negative 2. It is okay to put an equal sign here. This is not a linkage error because, I'm not linking the top one to F of R prime of negative 2. What was F of negative 2? What's F of negative 2, guys? Negative 1. So put a negative 1 in there. What is F prime of negative 1? Negative what? Negative 3/2. What's F prime of negative 2? 2/3. So it looks like it is negative 1. How are we feeling, guys? Letter F. Find the tangent line of g of x at x equals negative 2. What two things do I need for a tangent line? Guys, I don't hear you guys. Tell me again. Let YouTube hear you. Okay, well, Konduro screamed nice and loud. Point and slope, guys. We need a point. We need a slope. Thank you, Konduro. All right, here we go. How do I get my points? How do I get the point? I just have x equals negative 2. Enter the negative 2, guys. G of negative 2 equals, and I come up here to my table, and I look, G of negative 2 is 3. So there's my point. The point is negative 2, 3. How do I get a slope? Take a what? At what x value? Yeah, so I need G prime of negative 2. Go to your table, look for G prime of negative 2. G prime of negative 2 is 1/2. This is called your point slope formula. Y minus y1 equals slope, parenthesis x minus x1. John, why is it called point slope? Because m is slope and x1, y1 is point. So I'm going to write y minus 3 equals 1/2, parenthesis x minus a negative 2, so x plus 2. And there it is. This is your tangent. You can leave it alone if no multiple choice, and we're good. Do you guys feel okay? All right, there it is. We've done pretty good. I don't see any errors in our ways. I think we're good. That was all one question. Yeah, A, B, C, D, E. All right, here we go. Multiple choice. The graphs of the piecewise linear functions f and g are shown to the right. If the function h is defined by h of x equals f of x times g of x, then h prime of 2 equals, what rule do I got to do? Product. H prime of x equals first times derivative of the second plus the second times derivative of the first. Are we cool with that? All right, here we go, guys. Notice you have the graph of f and the graph of g, and they're all just nice linear lines. H prime of 2 equals f of 2, g prime of 2, plus g of 2, f prime of 2. So catch up to here. F of 2 I just get from my graph. I come up here. It looks like f of 2 is what y value? 4. Now I'm going to get g prime of 2. I'm going to get it from this graph as well. But g prime, remember what prime stands for, or derivative stands for? It stands for what? Slope. So what's the slope of this linear line? 1. The slope of g at 2. See? Rise 1 to the left, or to the right. Up 1, right 1. That's the slope of 1. All right, plus g of 2. G of 2 looks like it's what y value? 5. Times f prime of 2. Go to the f graph, and it looks like, what's the slope there? 2. You go up 2, right 1. See? Down 2, left 1. All right, there it is. We're done. 4 plus 10, 14. What'd you guys think? Not bad, right? All right, this one. I'm going to go slow as I can go, guys. 1 minus secant squared. The only properties you know for trig, for x approaching 0, these are the properties you guys know. You guys know limit as x approaches 0 of sine happy face x over happy face x equals 1. You know limit as x approaches 0 of tan happy face x over happy face x equals 1. What else do you guys know? Limit as x approaches cosine, I'm just going to say x this time, cosine x minus 1 over x equals 0. Which one am I going to use from all three of those bullets? Probably the tan one. Right? So another side note. Cosine squared theta plus sine squared theta equals 1. You guys know that, right? Well, we're trying to solve for this limit, but we need properties, Kanduru. Because I see 1 minus secant squared. So remember, the only way to get a secant squared out of this guy, out of the Valentine's formula, is if I divide everything by cosine squared, right? 1 divided by cosine squared is secant squared, and I'm going to get a tan squared. Look, cosine squared, cosine squared, cosine squared. 1 plus tan squared theta equals secant squared theta. And if I make it look like the numerator here, move that secant squared to the left, move that tan squared to the right. 1 minus secant squared theta equals a negative tan squared theta. Do you guys see the substitute that we're going to do? Yeah, I'm going to slow down. I'm going to substitute 1 minus secant squared 6x with negative tan squared 6x. And I'm going to use this property that I circled. So I'm going to write limit as x approaches 0. And I'm going to replace it. It's a negative tan squared. I'm going to keep the argument. 6x over, and I'm going to square this, 4x squared. Have I lost anyone? Yeah, I'm going to start doing a poll feature. I just haven't decided which one's the best. Maybe Kahoot. I don't know. We'll see. Like to poll you guys. Get data from you guys. Yeah, I'll just say answer the poll. And you can. Yeah, dude. Hopefully it won't distract. Oh, because I'm going to be using this property? That's a good question. All right, guys. So Ramos asked, why did I square the bottom? I'm going to be using this property. I'm going to expand it. But because the x is right there, I went ahead and wrote 4x squared so I can expand, so I can group one of the x's like this. You're probably looking at me and I'm like, I don't know what you're talking about, Chop. So I can do this. Negative tan. The 6x, I can't do anything about it. But see, x times tan, 6x over x, and then the 4. So here's my 4, 1 over 4. So I can do that. You know what I mean? Without it being squared, like without squaring the 2x, I can't group the x's like that. I just expanded it. Does everyone see what I did? It's still the same. It's still equivalent. All right. If you have colored pencils, here's where it's a good place to bring colored pencils out. What do I need to make this guy right here 1? Yeah, I need a 6. If I put a 6 there, that's magic. I got to balance it by putting what? A 6 in the numerator. So there's my 6 in the numerator in the third product there, third term of the product. I guess technically term is like the whole thing's the product. But anyways, you know what I mean. The first, second, third. All right. What about the second one here? What do I need? Another 6. If I put a 6 in the denominator, I need to put a 6 in the numerator. Okay, we're ready now. We're ready now. Here we go. So what is this limit? Well, this first green blob that I circled, that's a 1 or a -1 because there's a negative in the front. Then this second blob here, or second circle that I circle is 1 times 6 times 6 over 4. 36 divided by 4 is 9, but I have a negative in the front, so -9. Look at all those answer choices.
And we picked it, right?
Oh, there's no supporting work. I'm going to have to be like, nah. You got to have supporting work, right?
Look at all this supporting work.
Okay, all right, we're good. We're good. We're good. I don't want no beef. I'm a vegetarian. I stole that from a band named 303, but you guys probably never heard of it. All right, here we go. 303. 303. Yeah, don't worry about it. Don't worry about it. It's like it's poppy songs. All right, here we go. Here we go. Here we go. Here we go. So look at number 4. No calculator. This guys. This is actually pretty straightforward, but the algebra might trick you. I did this one earlier this morning. Y prime equals chain rule. What do I do first? 5 on the outside. Leave the inside alone. To what power? 4. Am I done? No. Then I got to do the derivative of the inside. What rule? Quotient. So here it is. I'm giant parenthesis bottom. X plus 1 times derivative of the top. What's the derivative of x? 1 plus or minus? Minus top times derivative of the bottom, which is just 1, all over bottom squared. You are done with calculus. The rest is just algebra. It's not extreme algebra. So let's first figure out the numerator of this quotient rule here. So x plus 1 times x, that's just going to be x plus 1. And then x times 1, that's just going to be minus x. So notice the x's zero out. Do you guys notice that? So here I am rewriting it. Y prime equals 5, parenthesis x over x plus 1, close it to the 4th power, times 1 over x plus 1 squared, close. Are we still okay? All right. Y prime equals, I'm going to go ahead and use law of exponents. That 5 is going to go next to that x there. 5x to the 4th. Are we okay with that? Over, notice this is going to be x plus 1 to the 4th. Law of exponents times 1 over x plus 1 squared. Again, continuing. In the numerator, I'm multiplying here. That's going to be 5x to the 4th. And then x plus 1 to the 4th times x plus 1 squared. That's going to be x plus 1 to what power? There you go. Which one is it? D as in Darren. Or Doug. Or Destiny. Or Denise. Or D-Nice. I'll stop. None of the above. You're funny. All right, here we go. What does this 2 mean, guys, on number 5? What does that 2 mean? The second derivative. So I'm going to write y equals sine x. What is the derivative of sine x? So cosine x. What's the derivative of cosine x? Here's how I show my work. Y prime, y double prime. And then I'm going to come back and I'm just going to write negative sine x. How do we feel? What's the derivative of secant x? Yeah, hopefully by now it should be becoming automatic, guys. What's the derivative of cosecant x? Nope. That's the next one. What's the derivative of cotangent x? Negative cosecant squared x. Make sure you know those. Derivative of secant is secant x tan x. The derivative of tan x is secant squared x. Make sure you know those, guys. All right, here we go. Number 6. Y equals cosine 2x. I want the derivative. What's the derivative of cosine? Negative sine. Keep the argument. Am I done? Times the derivative of your argument. What's the derivative of 2x? 2. Let's rewrite it nice and pretty. Negative 2 sine 2x. I look for that. Done. Cool or not cool? Okay. Let's go to number 7. They give you an expression, and they want to know which one represents f prime of x. So remember, write this down, guys. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Really, it's just your slope formula, right? Changing y over changing x. Which one of those, all right, guys, focus. Which one of those looks like they're doing that? Does letter A look like it's doing that? No, out. Does letter B look like it's doing that? Yeah, probably. H approaches 0, x plus h plus 4 minus, this looks like f of x over here, and this, oh, let me use the laser pointer. This guy looks like f of x right here, and this guy right here looks like f of x plus h. I had to pay extra for this laser. Did you know that? So I gotta use it. No, I really did. I had to get the pro feature to use the laser. So yeah, I guess it's cool. Okay. Letter C. Can it be letter C? No, it doesn't even have a limit expression. Can it be letter D? No, it looks funky. Look, it just has that plus h there on the side. Out. Letter E. Look at letter E. No, because they have h approaches x. They're very tricky, those stinkers. Letter B. Letter E has x, h approaches x. So a lot of people might have chosen that. All right, number 8. A free response problem. You're not going to have any free response because it's all delta, but it's good to know. Yeah, maybe this, I don't know. Well, okay, we'll talk. Here we go. A particle moves along the x-axis, so that means it's either moving left or right. So that at any time, all right, guys, focus. So that at any time t greater than or equal to 0, its position is given by, and this is my position equation. It just tells you where you are on the x-axis. Notice it says x of t. All right, guys. Well, we've been doing this many times, so we know already. Find the velocity. All right, guys, focus. Find the velocity of the particle at any time t. How do I find the velocity from position? Take a derivative. So here we go. I'm going to write v of t equals x prime of t. I'm showing the reader that I'm taking the derivative of position equals 3t squared minus 24t. That's all they wanted. Cool or not cool? Letter B, find the acceleration of the particle at any time t. How do I find acceleration? The derivative of which one? Velocity. You can also say second derivative of position. So here we go. I'm going to write, you just have to show one of them. I'm going to write a of t equals v prime of t. You know what? Just for kicks, x prime of t. There it is. I connected them all. I'm just taking a derivative of velocity. What's the derivative of 3t squared? 16 minus 24. Done. That's it. Are we okay? Letter C. Find all values of t for which the particle is at rest. When does the particle ever at rest? When the velocity is what? 0. So you just say, you're making a notation. I'm looking for what velocity is 0. And that's what I'm going to do. I'm going to come back and I'm going to say, well, velocity is this guy. 3t squared minus 24t equals 0. I can factor out a what? And a 3t. So I'm going to have t minus 8. And the only time that will equal 0 is if t equals 0 or if t equals 8. And I'm just going to make a little sentence. That's the future of your AP exams. They want you to write a sentence here. And all you got to do is just say particle is at rest when v of t equals 0, which occurs at t equals 0 and t equals 8. Done. Does that make sense to you guys? Okay. Letter D. Find the speed of the particle when its acceleration is 0. All right, steps. What do I do first? Set acceleration equal to 0. So I come back and I just write, well, I'm going to have to set that dude equal to 0. So what's my acceleration? 6t minus 24 equals 0. Now it just becomes a game of algebra. 6t equals 24. Divide both sides by 6. T equals 4. What do I do with that 4 seconds? Plug it in where? Into the velocity. Good job. Now, can speed ever be negative? No. So what if you get a negative answer, you're going to take the absolute value. So I'm going to write absolute value of v of 4, like that, equals absolute value. And then let's see, what's my velocity? 3 times 4 squared minus 24 times 4. Now, I'm a little warmed up because I remember this. I did this question this morning. 4 squared is 16. 16 times 3 is 48. Minus, if I have 4 quarters, that's $1, but I'm not at 25, I'm at 24. So that's 96. And 48 minus 96 is a negative 48. What's absolute value of negative 48? 48. So I'm going to write speed at t equals 4 seconds. Or it doesn't give me units, does it? Nope. Speed at t equals 4 is 48. If I had units, I would put them in there. I don't have any units. Last one on this one. During what intervals is the particle moving left, moving right? So real quick, you just say if velocity is negative, semicolon, moving left. This is how you say negative, guys. V of t less than 0, see? If velocity is positive, you're moving right. I bring back my velocity equation. V of t equals, let's see, what was it? 3t, t minus 8. I'm using the factored one. So what did I get? Remember when I found the t values where it's 0, 0, and 8? Between 0 and 8, so for all values between 0 and 8, v of t is negative. Hence, moving left during this interval. Does that make sense? No, ask me, guys. I can't read minds if you don't ask me questions. So I heard someone say no. If I were to make a number line, so here's a number line, and I'm going to say this is 0 and this is velocity, and 8. If I pick any number, give me any number between 0 and 8. 2. 3 times 2 is 6. 2 minus 8 is a negative number. Positive times a negative is a negative. I am negative between, velocity is negative between 0 and 8. So if you're negative, you're moving to the left. Right at 0 and right at 8, you're stopped. So notice I didn't put an equal sign. Cool or not cool? All right. And then for values greater than 8, for t greater than 8, I'm moving, velocity is what? Positive. For t greater than 8, velocity is positive. Hence, and I guess I should have put a comment there. Hence, moving right for t greater than 8. There it is. How do we feel, guys? Do you feel okay? Okay. Well, on tomorrow's test, you don't have any free responses. It's all delta. So you're gonna have easier problems.
You didn't know the first one?
No, not all of them is multiple choice. I think there are a few though. Yeah, some of it is like the same one that we had last time. In any form, find my derivative, stuff like that. All right, I think we're gonna need a calculator for this one because I see a whole bunch of decimals. All right, let's see what it says. A particle moves along a line so that at time t between 0 and pi, its position is given by, so here's my position equation. What is the velocity of the particle when its acceleration is 0? Okay, I'm not going to do anything by hand. I'm going to show you how I'm going to do it with a calculator. You could probably find your t value by hand. It doesn't look like it would be too extreme. But here's my calculator. Yeah, this for this one, yes. On this test, we let you use a calculator. Oh, look at all that freak out stuff. What I would do is I would type this into y1 like so. -4 cosine x minus x squared over 2 plus 10. So I'm going to go to my calculator. -4, I already forgot, cosine x. What else? Plus, no, minus. How come you guys didn't tell me? Minus alpha y equals x squared over what? Over 2 plus 10. Okay. There's my derivative. Let's see. There's my original position function. I'm trying to think how far deep do I want to go. All right. I'm going to tell y2 to be the derivative of y1, and I'm going to tell y3 to be the derivative of y2. Relax. It's going to be simple. Push the math button. Scroll down. And do you see where it says n deriv? That stands for numeric derivative. Push it. I'm going to put x. I'm going to push alpha trace y1. And I'm going to push x again. Does everyone's y2 look like that? On y3, I'm going to tell it to take the derivative of what? y2. Why am I doing that? I'm looking for where acceleration is 0. Good job. So there it is. I'll make sure that we understand what we're doing here, the logic. y1 is position, y2 is velocity, and y3 is acceleration. I'm going to turn off y1 and y2. y1, y2. See what I did there, guys? Yeah, I just went to the equal sign and I pushed enter. So when you push enter, it turns off y1 and y2. Don't push graph yet. I'm going to click on window. I'm only looking between what and what? Between, that's what you're going to do. I'm going to look between 0 and pi. And then let's see, what else am I going to do? I just want to see where the acceleration is 0. So I'm going to hover around the x-axis, -2 to 2, or maybe -1 to 1. It depends. Cool or not cool? I'm going to push graph. And there it is. This is my acceleration graph, or acceleration curve. So right there, or across the x-axis, is where the value is 0. Does that make sense to you guys? What's up? What does it say? Okay, click. That means click on window. Do you have x min as 0, x max as pi? Do you have y min as -2, y max as 2? Okay, click on y equals. Did you type in your equation, or do you have any of the plots on? Make sure it says negative and minus. I'll go over there in a little bit. Who did not get this, guys? Because this is a skill you're going to have to know. you guys know how to do it, guys. So it's a skill. Okay. Your calculator. All right, guys. Let's focus. Your calculator is working really, really hard. Unless you have a CPU like this or GPU, obviously the chip in the calculator is not as strong as the chip in this laptop here. So yours is going to take a while. But it shouldn't take forever. It should be like within 30 seconds. You should have, I would say, 30 seconds to a minute. There are ways to make it faster, but the faster you make it, the less accurate it'll be. You see this where it says trace step? That's how often it does a pixel. So there are ways to make it faster. If you put 0.1, it'll go faster, but it won't be as accurate. Does that make sense? So I would leave it alone for accuracy. So now I would leave it alone for accuracy. Okay, does everyone have this graph here? So check it out, guys. Focus, because this is something new that we haven't done with you guys. I want that 0. So the calculator has a lot of commands that you can do. You remember from last year from pre-cal. Second, calculate, and look at all the things it can do. You can even find a derivative. Look, dy dx at a certain point. I'm gonna go to don't use number 6, by the way. I'm gonna go to 0. Yeah, don't use number 6 because that graphing window is not as accurate as their home window. I'm gonna go to 0, and it's gonna say left bound. All right, guys, focus. Left bound, go to the left of that intersect or that 0, and then right bound, go to the right. It's gonna say guess. If you have several, go to the one that's closest to, just like last year. You only have one, so you can just push enter. Boom, and there it is. 1.318116, and this is perfect because it says y equals 0 there. Did you get that value? Okay, check it out. Negative 2 and 2. Oh. Okay, let me see. It has to be radius.
I don't know.
Okay. All right, guys. Finally, here we go. All right, come on, Boston, focus, miss. So here we go. You see how we already found? Okay, let me do it again. Second, calculate number 2, left bound, right bound. Okay, you notice that it says that it's stored that the 0 is 1.318116. For computer science, for you computer science nerds, this is called a register. And notice if I go X and I push enter, it's that value. Now, don't I have the velocity equation in Y2? Yes, look, I'll do it again. So when you find your calculation, your 0, second number 2, and then it's going to say left bound, go to the left, enter. You can push 1, enter, and then right bound, you can push 2, enter. And then you should have this, it should be, all of you should have that same number, 1.318116. If you go to the home screen and you push X, it should come out like that as well. I like to save this number into a letter other than X because X is always being changed every time you use it again. All right, here's the big magic. It's not magic, but let's work smarter. You guys ready? You already have your velocity equation in Y2. Look, Y2, you're taking the derivative of Y1. Do you guys see that? So you don't have to do anything again. You can just recall Y2. Go alpha, trace, Y2. See? And then I'm just going to put it, give me that at A, which is the value that I stored, that 1.31. There's my velocity at A. And I got 2. How do you store it? It's in the next to the number 1, stow. Push X and then stow and then alpha A. Okay, ask me, Ro. Have no idea about what? No, there's several different ways to do it. So the answer is. Hey, ask me. Ask me. I stored that answer to A, and then I just called y2 alpha trace, and you just go to the y2 because that's the velocity, and then I open up a parenthesis and I put A in there. How do you what? Well, next time you use A, you're gonna replace it.
What if I use A?
Well, what are you trying to do? What are you trying to accomplish?
Reset it.
Just reset it. Reset everything, and when you reset it, everything goes back to normal. You're not. Yeah, you can reset. All right, guys, we're almost done, guys. All right. Talk to me about number 9 sometime later if you don't understand how we did it. You don't have to use the calculator the way we did it if you thought it was too complicated. Number 10. Number 10, if I remember correctly, this is from the 2008 AP exam that I stole this question from. I think it's in your AP exam that I gave to you guys from the 2008 one. All right, here we go. I want the derivative at pi over 9, so I'm going to write f prime of x equals, what's the root of a cosine? Negative sign, keep the argument, 3x. Am I done? Times what? 3. So f prime of x equals negative 3 sine 3x. Now what am I going to insert? Pi over 9. So f prime of pi over 9 equals negative 3 sine. When I plug in pi over 9, 3 goes into 9 3 times. So I get sine of pi over 3. Do you remember what sine of pi over 3 is? What is it? Look for that answer. Yeah, because it's 60 degrees and it's a sine.
Oh, shoot.
Are we okay? All right, let's go to number 11. Let f be the function defined above where c and d are constants. If f is differentiable at x equals 2, what is the value of c and d? All right, guys, focus. For you to be differential, you need to be continuous, and the left-hand derivative has to equal the right-hand derivative. So let's do that first. Continuous at 2. So equation number 1, 2c plus d equals, plug in a 2, 2 squared is 4, 4 minus 2c. That's equation number 1. Yay or nay? Equation number 2, take a derivative and then plug in a 2. So the derivative is going to be c equals 2x minus c. Do you guys see that or no? I just took a derivative because for it to be continuous and differentiable, the derivative from the left has to equal the derivative from the right. And the y value from the left has to equal the y value from the right. So that's number 1. Here's number 2. I'm going to plug in what value? A 2. So 2c equals 4. Does everyone see where I got that? Because I moved the c to the left. Focus, miss. Focus, focus. Is everyone okay so far? I moved the c to the left, guys, and then I inserted x equals 2. C plus c is 2, right? And then 2 times 2 is 4. Okay, the derivative of cx plus d is c, and the derivative of x squared plus minus cx is 2x minus 1 minus c. Yes or no? And you see this c here? I went plus c, so 2c equals 2x. And then I need to be differential at what x value? 2. So if I need to be differential at x equals 2, I plugged in a 2 in for x. 2c equals 4. Divide both sides by 2. C equals 2. What happened, Kunduru? Now that we know that C is 2, I'm going to plug it in right here and right here to get the D. So 2 times 2 is 4. 4 plus D equals 4 minus 4, I guess, or 2 times 2, yeah. So it looks like D equals negative 4, because 4 minus 4 is 0. When I move that 4 to the other side, it's negative 4. Okay. What happens to Lolly? So C plus D, 2 minus 4, so negative 2. Should we do it again from scratch? All right, guys, let's do it again from scratch. Yeah, because there's a lot of people that are confused. Okay. All right, guys, focus. So I want to be continuous and differential. If you want to be differential, you got to be continuous. Yes or no? So I got to be continuous at x equals 2. Plug in a 2. So plug in a 2 for x. So 2c plus d equals 4 minus 2c. Cool or not cool? That's equation number 1. I just plugged in a 2. I just plugged in a 2 for x. 2c plus d equals 2 squared 4 minus 2c. Step 2, derivatives. The purpose of, okay, say it again. It has to be continuous. And then for it to be a smooth transition, the left side, the left derivative and the right derivative have to be the same. So it can be a nice smooth transition. So the derivative from the left-hand side is just c. And the derivative from the right-hand side is 2x minus c. Now this has to happen at x equals 2. So I plug in x equals 2 into here. So, and I move that c to the other side. 2c equals 4. So c equals 2. See? Once I knew that c was 2, I plugged it in there and there. Really, you can just move that c to the other side. But 4 plus d equals 4 minus 4. 4 minus 4 is 0. Move that 4 to the other side. D equals negative 4. So d is negative 4. C is 2. So 2 plus negative 4 is negative 2. Cool? All right. Number 12. X is approaching infinity. And behavior, guys. And behavior. Limit as x approaches infinity of 2x squared over negative x squared. What am I going to approach? Negative 2. Those questions are in there. Yes. Ask. Ms. Ruiz, you had a question? All right, number 13. Try to do this one with arithmetic, I guess, and just logic. Get a common denominator with the ones. So I'm going to rewrite it, guys. Limit as h approaches 0, h squared over h squared minus 49 over h squared over h squared over h squared plus 49 over h squared. So look what you have. You have h squared minus 49 over h squared over h squared plus 49 over h squared. Catch up to there. And I guess I'm doing bad math here. I should say limit. Now, all right, guys, focus, focus, focus. Yes. Yeah, because see how it says h equals 0? Okay, all right, guys. I can't do direct substitution because h equals 0. So then now you have to figure out, like, what else can we do? And you're like, well, I have a 1 here, and I can turn that into h squared over h squared because of common denominator in the numerator. And the same thing with that one, h squared over h squared because of common denominator in the denominator. Does that make sense? And then something happens that makes this transition really simple. Notice what happens to the h squares, guys. They cancel out. And now that they cancel out, look what you have. Limit as h approaches 0 of h squared minus 49 over h squared plus 49. Now can I do direct substitution? Can I do direct substitution now? Yes, you can. You get negative 49 over a positive 49, which is negative 1.